Good morning, everyone. Let's wait a few more minutes for people to join, but please sign in the shared doc. I'll paste a link again in the chat. We are online 406. We'll continue where we left off yesterday. Look at tidyverse, few more verbs, for instance, to create new columns from existing ones, and then look at plotting. In terms of schedule, same as yesterday. We'll have a break, half an hour break at 11, and then finish by 1 p.m. Please check in with your name and with one thing, your favorite thing you learned yesterday, and let's say an optional book recommendation if something comes to mind. I recently came across the Climate book by Greta, which is a compilation of various science facts and political pieces, encouraging some more action on climate change. So I quite like that. So today we will look more at plots. So hopefully this will be useful. If you like the base R plot functionality, then you'll like ggplot2, I think. That's a library designed to be usable with this pipe symbol. Yeah, feel free to unmute and introduce your book if you decided to recommend one. I'll recommend also a book on topic below. It's also freely available online. It's called R for Data Science by Hadley Wickham and Garrett Grolman, which goes in more details on both plotting and tidyverse, among other things. Also, how to work with strings. It's a very good book. I think it's in the second edition now. Came out a few years ago. Oh, now also Minna Sittinkaya Rundell joined as an author. I didn't realize. I think she is at Edinburgh, or at least she was a lecturer at Edinburgh for a while. Hi Jeffrey, thanks for sharing again the link. So when you join later, you might not be able to access the chat from before on this platform, so it's slightly inconvenient. Okay, please sign in online 412 and below. So Hadley Wickham, one of the authors, is very prominent figure in the R community, as he has designed these libraries for tidyverse, many of them for tidyverse and ggplot. And here on his website, he's got a few links to other books, also one on more advanced topics if you want to implement your own library at some point. Okay, let's get started. So we can continue with the exercise using pipes to subset surveys data of animals collected before year 1995 and keep only columns year, sex, and weight. So this is a quick exercise to get back into it. Let me share my screen. Okay. Hopefully you can see my screen. Is this font size all right? I've been looking at profiling, so if we've got some times, I'll mention some ways to check performance of your code. Okay, so can someone remind me what the pipe symbol looks like? And what it does? Feel free to unmute if you want. Alternatively, drop some code into the shared document. So I prefer the shared document because it's more easy to copy paste things compared to this online platform. But yes, so the pipe symbol is this percentage greater than, and then another percentage sign. And it comes from a grid R package, which is part of tidyverse, as you remember. There's also a command, a shortcut command. Do you remember the shortcut? I guess it's a play on René Magritte and Cécile Pound piece of art. That's not a pipe. So that's a library. If you type question mark Magritte R, this will describe the library. You should see it in the help pane. And that's a convenience function, so it explains this generically like this. It helps to replace a function call with this notation. So instead of writing f of x, we write x streams through f considered as a pipeline stage in a pipeline, left to right. So kind of data streams through the set of functions one by one. And there's some more esoteric pipes, but we'll stick with the base pipe. So You can see how a data analysis pipeline can look like. Read the data, do something with it, and then show some parts of it. But this last part could also be analyze, plot, create derivative data set, and so on. So we can have a data cleaning pipeline, and then we can have an analysis pipeline, and so on. Okay, let's practice this a little bit more. So if someone has a solution to this exercise, please share your code and we'll discuss it together, or you can describe it. We can work on the service data as yesterday. If you changed it, you might need to reread the file again. Okay. The disadvantage of the shared doc, that's more easy to step on each other's toes when writing. So make sure you pick a separate line when you add your code. But yeah, so we start with the data, and in this case, we don't, strictly speaking, need to save it. Yeah, there's a suggestion here with filter. And you see how it's more convenient notation. So we can build this pipeline stage by stage. First, we can create first stage and check the data looks as expected. So I wonder if this will work. So there is also a summarize function, but we could use the data set to get some stats, perhaps. So we can see the maximum and minimum year. So the largest is 1994. So we can first make sure that step correctly worked. And next we can continue creating our pipeline and then select the columns we want. And then we can see we've got 3 columns and the dimensions are correct. Or at least we've got 3 columns. One important consideration is the order. In a way, for these operations, we could, because we're keeping the year, we could have done select first and filter then. So depending on your data, if you've got a large data set, it might matter which way around you do those steps. So perhaps you could select first and then filter, because then the data in memory would be smaller. But in practice, it might, on your particular data set, it might not make a big difference. So then later we might look briefly at a package called microbenchmark to test your code, to time it. Okay, any questions about using the pipe and the style of applying it? Okay, next, please spend a few minutes to have a look at the documentation for the mutate function. First, if you restart the environment, if you're seeing any errors, you need to load the library if it's not loaded yet. Like typing library tidyverse, and then maybe your survey's data is not loaded, or you've changed it, so you might need to reload the data using read CSV file as specified in the shared doc. Select being applied to function. It's difficult to say without seeing the code. Could you please paste your code into the shared doc? Okay, I've changed the code slightly in the shared doc because it had some initial bit of syntax that might interfere if you use all the thing. I would also suggest to change the name slightly. So if you want to save it, do you still get the error? You can use the cheat sheet to look up Okay, so the summary bit needs to be removed. Yeah, this was only temporary. So if you write it this way, this should work. Great. Okay, it looks like it's fixed now. Anyone found any information about what mutate does? So this function, I would say, it's less self-descriptive of them, but it creates, it mutates the data set, and usually we use it to create a new column. So for example, we can take surveys and add a new column, for example, based on existing ones. So we can refer to weight, and we introduce a new column by name. We give it a new name, weight kilograms, and then we divide weight, whatever is in the column weight by 1,000, and that's done in the vectorized fashion. So for each element, a new element in the new column is created based on this equation. And if we run it, we can see we've got one extra column now. And if we save it, we could examine it. So what we can do, we can also create multiple new columns in one call. Times 2.2. So we also create weight in pounds. And then if we pipe this to view, we can check the outputs. Okay, I must also say that the syntax matters in a way. You can't put a pipe, for example, at the beginning of the line. That's based on the syntax limitations. But now we can see, and it's kind of dot. It says this intermediate data set. It's not saved, it doesn't have a name, but we can pipe it into this view function, and we can examine that we've got new columns. Okay, let's have let's have another quick exercise on this. I'll also paste it into the shared doc. Okay. So the task is to create a new data frame from service data. So that it contains only species ID column and a new column called hindfoot CM, which is hindfoot length in centimeters, based on hindfoot length currently in millimeters. Yeah. Okay. And there should be no missing values there, as well as all values should be less than 3. So you can build this pipeline step by step and think about the order in which you need to apply those steps. Okay, let's spend a few minutes on this. We are on line 447 in the shared doc. And once you've got a solution, feel free to paste it and we will discuss it together. Okay, I will clean up my environment a bit in the meantime. Okay, let's start by deciding that we want to save the results. We will work on the service data, and then I've got a few pipeline stages here. Any suggestions? What shall we do next? Feel free to unmute. Or copy paste your code into the shared doc. So
I have put some code in the shared doc. I don't think it's right, but it's all I've got.
okay. Yeah, let's see. So I think this hashtag symbol is the comment sign, so it's not really needed. Okay, I'll take it and see how it runs. So instead of viewing it, I will save it. So every time it runs, okay, there's a bit missing here. So each stage needs to be connected through the pipeline. So, and we can format the code. Control Shift A will kind of beautify a bit. Okay, let's see what we've got. So at least it runs. So there was no error now, and we've got a new 2 variables. Okay, there's still. Okay, so what have we got? We've got the handfoot length and species ID. Any comments, suggestions? Hindfoot length. Okay, so here what happens is hindfoot length will be overwritten by its value times 10. We want a new column called hindfoot CM. So it's a good idea not to overwrite existing data. So that's why we're not overwriting service, because if we make a mistake, then the service data will be broken and we would need to reread it again. Okay, let's try this. And then we can again check how it looks like. You see, now we've got a new column with a new name. And we can see it is, in fact, 10 times the previous. Although not sure the direction of translation is correct. Anyone else has got any comments on?
Yeah, I've posted something in the pad, but
right, yeah.
I can't recall how to filter out the missing values, because that's what I probably.
So I would suggest, we need to divide because we've got it in millimeters, so it's the smaller values. So we need. I think that's right.
Yeah, I wouldn't. I would probably start with filtering the data first, to remove all the NAs.
Yeah, that's a good idea. Okay, let's see. Do you remember what function we can use?
I don't remember to do that.
So yesterday, how did we check exclude something that was not so we did exclude all NAs by keeping what's not a missing value, right? So there was a function called isNA.
That's getting that mixed up with data frames from the Python work. Okay, see that now. Okay.
But then we need those that are not missing. And we could run only up to this stage. So this command will prevent the rest of the pipeline from running. So we can check a quick scan. Looks like there are no NAs. We can also summarize the data. Okay, next step. If we select, we want to keep the new, but this is the difficulty. Sorry. So if we select only the new one, then we haven't created it yet, so we cannot select to keep only the new column. This means we need to reorder things. So first we create a new column from existing ones, and then we select. So would this work? Okay, I'm taking the hint from the shared doc that we still need to satisfy this requirement that we want only hindfoot smaller than 3.
Yeah, I think I put one in the shared doc, but it doesn't work that I thought would work. But yeah, I guess I was just wondering if you could explain why it doesn't work. I think it's something to do with the hindfoot CM column not being like properly created. I don't know.
Okay, here
I actually got the same error.
we've got a slightly different error here. So let's fix this code briefly first. So we create a new column, and then we want to keep that. So we did select the wrong column. That's why we couldn't. So this explains this error, that we couldn't find it because we selected this one. This runs, and let's quickly examine if it did. Looks all right to me. Okay, so is it the code in green you want me to test run?
Yeah, I think I was just getting this similar error to you, but I was a bit confused about which one I've done the wrong way around.
So we select those two. Yeah, I think select needs to happen later. Because I mean it still works, but then we'll keep so this syntax is not quite right, because this is using the so this is not a tidyverse verb, so this cannot act as a pipeline stage. And this means we need to use filter here. But all tidyverse verbs are designed to work together. So let's see. This looks fine, except that we still kept the old column. But then we could also drop it by selecting again. But then you see, if we select here again, so we have maybe one extra stage. For this pipeline, that's not a problem. If you've got huge data set, then it might become important whether you filter first or select first. Okay, I hope this is useful to kind of break this code down a bit in more detail. But that's mutate, in another one of those verbs, and there are a few more. So we can't go through all of them today, but let's consider group by and summarize. So they're useful functions to get groupings of values and summary. Are there any questions about mutate or about building pipelines in general? So often we would use group by using a categorical variable, which could be a factor. Let's have a look at an example. We'll work again with the service data. Group by. We'll use sex and species ID. So this will create internal groupings of the data and then summarize. If we want to have mean weight, and then on the right hand side we define how we calculate it based on the other columns, for instance weight, and we want to remove missing values for this calculation, and let's view only the last part of the data frame. Okay, something didn't quite work out as expected. Let's see. I don't think that's the syntax of this. But what we can see here at least is that we've got a new subdata frame or table, and we've got for each group by species ID, we've got some entries. But this is also, let's view the whole thing. Okay, this tail function didn't quite do what I was expecting it to do. So here we can see we've got for each species ID and sex, so we're grouping by two things. If we take one step back and group only, let's say by sex, then we would get a group for each, and we still got also a grouping for missing values. Okay, so to avoid this, we can filter by NA first to remove it. Remember again this function, it's quite handy, is not NA, wait, species ID. Okay, that's interesting. What's missing? Can you spot the typo?
your continuation mark.
Yes, we need we need this at every end of the line. If we put it at the beginning of the line, it would also complain. So the syntax is like so, because it does something with the way functions or function objects works in R, and we need to stick to the syntax. But now we can see we've got for each pair of sex and species IDs a value, which is quite useful, so we can quickly summarize things in this way. There is a shortcut function for counting. If we only need the number for each value, we could use count. And this is a shortcut for this notation. Okay, I'll copy this also to the shared doc. So this is a very brief introduction to this kind of functions, but this way we can apply something that's called split, apply, combine methodology. This means we group things, and then we can apply some analysis to the groups, and then we can combine them to get some result. In the interest of time, I will not go into more details on this, but I suggest later you revise this part of material in your own time. Let me briefly share the browser window. Are there any questions in the meantime?
I have a question, please.
Yep.
Why is the exclamation mark needed at the beginning of the is?
Oh, this is not. It's logical not. So we reverse the truth value of this. So we want to filter. So how filter is defined is keep everything for which the condition is true. So if we keep only is NA for weight, we keep only records for which the weight is missing. So we need to not do that, but do the opposite. So keep only records for which weight value is not NA.
So the exclamation mark reverses.
Yeah. So this is logical not.
And does that work for most commands?
This works for logical expressions. So you can reverse the value that's true. Not true makes it false. So you can, if you've got a logical expression, you can use not. For instance, not true and not false. I guess it needs to be grouped. Sorry, the end is also.
Sorry, I can't see your screen at the moment.
Okay, I'm typing not true and not false into the console, so you can play around with these logical expressions to get a feeling for what does that do. But One last thing, 1 second. Just quickly check something. There is a help page for this. I'll put it in the shared doc, the syntax. So you can type question mark and then tick marks the exclamation mark to get help on that logical operators.
Okay, thank you.
Okay, where was I? I was sharing something. Okay, let's see. Somehow it wants me to share 2 times. Yes, it looks like this. Hope you can see. Oh, the windows. Okay. We were in the dplyr section still. Manipulating and analyzing data, but we're not gonna go through all of this in the interest of time to also do some more plotting today. So we have seen filtering, selecting, so selecting columns, selecting rows based on a condition. We have seen mutate to add our new columns. We have seen group by, summarize, count to kind of create summaries. And then, so something we will skip is reshaping table format. So as a reminder of a tidy data set, we've got each variable for its own column, each observation has its own row, each value is its own cell, and each type has its of observational unit forms a table. So, but often data comes in a different shape, and tidyr offers some functions that can help us reshape data. And this figure nicely shows visually what reshaping can mean. So here we use this pivot longer function to get a wide format from a narrow format. Narrow format uses less space to store things, but you can see how the values are sort of jumbled up together a bit more. And this transformations helps us to get us into the data frame format, the wide format, that might be nice to use when plotting. So have a look at this material. So this is another visual representation of going from long format to wide format and back. Okay, yeah, so in this case, I might have made a mistake in the previous sentence. So wide format is the more compact, but you could see how there's one value encoded in the column names. Instead, we want this explicit format where now we can group by genus here, which we couldn't have done within this format. So those are these pivoting functions, and we can go either way. But we will not do this. Let's have a quick look at exporting data. So we have seen the read CSV function, and there is also a corresponding write CSV function we can use to store data. And the syntax is like so. Okay, I'll switch back to RStudio. Okay, hope you can see it. So this is useful when maybe you have done some analysis and you want to share the results with someone. So we don't have the survey's complete data set, but let's say we store surveys 100 centimeters subset. So maybe someone needs to plot it and you quickly send a small subset of the data. Something like this, and if we run this, hopefully there is no error, and then on the files and the data we can see a new file appearing that was not there before. Let's spend a minute on this. So write some data frame to file. You can write the surveys itself, the same data frame, but then choose a different name so you could see that the file was in fact created in your project in the directory structure. And let me know if you experience any issues. This write CSV function is part of tidyverse as well. So there is write.csv, which is the kind of base R function. That's not what we're using. We use write_CSV. CSV, comma separated values. But we can specify a different delimiter. So often the arguments would be explained in the help, and then often there are some examples. There's also corresponding write_tsv function, which writes tab separated values. Might be useful if you use already comma somewhere else, which then would create some issues. Okay, let's have a quick poll. Online 492. Please add a plus if all went well or if you need some assistance. So to summarize, we've seen part of the tidyverse that mostly refers to the dplyr package, and used select to choose variables from a data frame, used filter to choose data based on conditional expression or values, and then we used mutate to create new variables. We also used briefly group by and summarize to work with subsets on data or group them by some categorical variable or multiple variables. So this way we can also get summaries not for the whole data set, but also by groups. Okay. Okay, let's start on ggplot2 because that's also quite a lengthy topic, and we might not go through all the materials, but as a reminder, the materials are available online. Oh, I see there are some issues. So if object is not found, it generally suggests you named it somehow differently, or maybe you didn't save it. So if you had only view applied, this will show intermediate data set and then drop it. We need to ensure that it appears under this data pane to save it. You can save surveys instead, but don't call it surveys in the same way the original data is called, but call it surveys test or something. So not surveys CSV, but so if you save it under temp, then you need to provide reference to temp here.
How did you save the Heimfort CM1 as a data frame?
Using this notation. So Hindfoot CM, it's only a label. This is the kind of the text we choose for it. So how I did it is like this. If you've chosen a different name, then you need to use that name when saving the data set. So it's, I thought it was here somewhere in the shared doc as well. Okay, I'll also post it there. I think that's the same, right? Yeah. Okay, could you check again if you rerun that, copy paste that code into your R code window and then rerun it? Okay, so I've got the service Handfoot CM removed, so it's not showing in the environment pane. Then I run this pipeline, and it will run all the stages, and we can see what it runs here. There was no error. We can see this got created. We can examine the result, and then writing it to file should succeed. And this would appear here, this separate file. We can view a file as well. So you could see it's a plain text file with comma separating the values for the variables. Please update the poll if that succeeded for you. If not, we should fix this before we move on, because this is the important part. This is how we can save data and share data later on with someone else, or put it on version control, or things like this. Any other issues, please let me know in the chat or in the shared doc. Otherwise, we'll move on to the visualization part. We'll look at producing some plots, maybe sketch plots, box plots, maybe line plots for time series data. Let's see how much time we've got left.
So
and then we'll look at.
Oh.
Yes.
Hello. So I added the extra line above the survey's hindfoot thing, and then that worked. But when I rerun the write CSV thing, it says can I open file for writing, and then it opens, like, I guess where I've saved it or something. But I don't know what it means.
So when you write, you've got the hindfoot CM under data. You can view it, and it shows us 2 columns. Yes.
Hindfoot CM data. Yeah, it does. Yeah.
Okay. Then we need to check that the file structure, it's kind of the same. You've got a project, an R project, so under files you can see this rproj file and some folders, and one is called data, right?
No, where was this? Is this meant to be inside?
Inside your home directory, for each user, this will be a different directory, but we have created a project in the beginning. If you're working with the same project.
So it's meant to be inside there. Right.
It's meant to have a data subfolder. If you don't have it, you can create it by clicking on this create new folder file, because this call expects this to be there. It will not create one for you. If it's not there, you need to make sure it's there, or you can remove it from here, and then the data will be saved into the working directory. But it's good practice to have code and data and raw data separate. So here we can see it appeared in the top level directory under here.
I think, yeah, it's worked now. Thank you.
And then we can remove the file also using the interface. We don't need it. Okay, great. Yeah, I think that's good to get this to this checkpoint. And now we can move on to ggplot2, which is I don't know if someone has an idea why it's called ggplot. Any gamers in the room? It doesn't stand for good game, it stands for grammar of graphics, and there's a formal way behind it. Kind of thinking about how we build graphs in layers from data and visual elements. And this is reflected in the way we call this ggplot function. We need library tidyverse to include ggplot. So sometimes you might start plotting and you don't find ggplot, then likely you need to load the library first, and you need to install it. And you can also use this package pane to check which libraries you've got. For instance, I would say tidyverse should be here, yes. So you can sort of click and install, and it's also worth updating your libraries every now and then, because R keeps improving and there are performance and bug fixes and so on. Okay. And this structure reflects this kind of theoretical background of grammar of graphics. We're not gonna delve into the grammar itself, but it's kind of semi-formal way to describe figures and systematically build them. So we've got data, this is what will be presented. Then we've got aesthetics and mappings. We'll get into it, what it is, and then some geom functions. So for example, whether we want points or lines to represent the data. And hopefully this will become clear in a moment. So let's load service complete data set using the read CSV function _CSV. And we'll take it from the data folder or wherever. You might need to change this if you don't have the data folder but have the data somewhere else relative to the working directory. So service complete. There is also a way to import the data from text. Okay, it might need to install something for me, but yeah, there's also like a GUI way to import data. If you want a dialog that shows the kind of browse window, you can find the file in the browse window and go this way. But we'll stick to the programmatic way here. Didn't exist. Okay, this might be because we had created in the steps before. Okay, my bad, sorry. Let's create it first. Oh, we created from... So there's one step that... that I missed. Sorry for that. I'll in the interest of time, I'll copy paste this into the shared doc. So what is happening here is 1 second. So we want to extract, like, remove NAs, extract most common species, and keep only those most common species. So this is the data preparation steps, and if we run this, hopefully this will work. We've got fewer records, but this will make the plotting easier. And then if we write this as complete, then we can load it again. Okay. Okay, so please take this from the shared doc, and now read CSV should work, because now we've got the file there. Okay, there's a question. Yeah, you will have the access to this online doc, but this is not it's not backed up, or it will not be kept there for a long time. So if you can copy everything from them, but I would say the reference materials is not the shared doc, but the actual Carpentry's materials. So this is the link at the visualization section, for example, this data Carpentry org ecology lesson, and then visualization. Okay. Let's do a quick poll. If you were able to get the data, we're on line 526. If you got the data only through the analysis steps without reading and writing, that's also fine. So we can continue with the grammar of graphics part. Okay, great. Let's move on. Looks like everyone's got it now. Yes, the website I've shown, this is the Carpentry's materials. So the link is, I've posted various links in the shared document. These are all the section headers, like manipulating data as a section header in those materials, and so on. I hope you can find it. Okay, let's dive into the ggplot stuff. So, ggplot is this function that will help us work with plotting. And we need to provide the data first, so we will use the service complete dataset. And we can see first, when we only provide the data, we've got the plot in the plot pane, but it's only gray background. There are no graphical elements yet. So the data is already associated with this canvas, but there are no aesthetics mappings according to this grammar of graphics. So we will need to add those. And how do we do this? So we can specify global mapping like so, using this as functions, which is shortcut for aesthetics. And we will use weight as on the x-axis and plot it against hind foot length. On the y-axis. We can see, we don't see the data points yet because we haven't selected the geom, but we can see the axis already in the labels. So these are the aesthetics components. Okay, I'll copy this line again. So now we will complete it by and this is similar syntax as the pipe syntax, but we will use the plus in ggplot world. And there are various geom functions. We can use geom point. So then for each data point, we will have a point appear. And hopefully you could see this type of figure. It's not very pretty, but it's there. You can click on the zoom to have it pop out. If I do this, you won't be seeing the popped out because of the sharing, how the sharing works, but the screen sharing. But if I sort of stretch it for a moment, so this is how it would look like once it's popped out as a separate window. I hope you can get that view. Okay. So you can use this to hide a part of the window. So hide the environment for now. And with this plot pane, we can walk around between the plots we've generated so far. And to delete one, we can press this, and yes, it will delete it if we don't need it. And then we can export it this way, or also programmatically, which we'll see in a moment. There are many other geoms. Let's see if ggplot has a vignette. That's something else. Okay. But there's a good cheat sheet for ggplot. I'll post the link in the shared doc. Okay, hopefully you were able to reproduce this behavior by typing along with. And this is how we build the plots from data. Let's explore this a bit further. Okay, what have we got here? So we can play around with various options. For instance, we can see an issue with this plot. It's overplotting. The dots are being placed on top of each other, so we can't really see where's the most dense region of the figure. There is one thing we can specify is this alpha value. This means each plot will be plotted transparently with some transparency level, and we can vary this. If we run this, we get different type of plots. So this way we can see where the main groups of points are. We can also change the colors. Oh, let's do that here. So we can have also a static specifier for each of the geoms. So this sort of overrides the global one. Okay, so now we've got assigned a color to each of the points based on species ID. And this way we can see sort of clusters in the data with some overlap. Okay, let's do a quick exercise. And the exercise is to create a scatter plot of weight over species ID with plot types showing different colors. And this is also something for discussion. And plot types. There's a column called plot type, I think. So, you know, we have a plot IDs in the data, and they also have types. Probably the type of soil, maybe. Or maybe someone got excluded from the plot. Any suggestions, please paste into the shared doc. And we'll discuss those before the break. suggestions, please add to the shared doc. Or if you've got any questions, feel free to unmute and ask away.
Hello. What does the 0.05 bit mean? Like alpha equals 0.05? Like what is
Kind of the percent strength of the dot. The smaller the number, the more transparent a single dot will be in the display.
Okay, thank
So
you.
1 means 100% solid, and then this may be 5% transparent, something like this.
Is 5% like 0.05 used the most? Is it like a standard?
No, it's just up to you to pick a value that looks good or like that shows the data best. So if
Okay,
we
thanks.
use by default, I think it uses 1, but this can lead to overplotting. If you have many dots on top of the same color place, you know what I mean. Like overplotting means if we draw data on top of each other, if we don't use alpha, small alpha value, it looks the same as a single dot. This might hide the data and we might get a slightly misinformed view of the data.
Yeah, okay.
But this way we can see kind of the clustering a bit more. Okay, so let's finish the exercise before we break. We can start in the same fashion, so we need to use ggplot function and then presumably some geom. Let's stick to points for now, but you could see there are many different geoms around. For instance, box plot. We'll have a look after the break. Histogram and so on. So plenty of options. And then there are also other packages where you can map data to a geographical map and things like this. We're not going to do this in this workshop, but there's a very vibrant visualization community in the R community. So we need to specify the data. Then the statics mapping. And this is part of the sort of ggplot syntax. We need to stick to that. So we'll stick with surveys complete. You can tab complete this. And the editor will suggest some data. So the mapping, I like to structure it this way for readability, so we can move it to the next line and align it vertically. X is species ID and Y is weight. And we could see how it looks like with points without colors. Okay, this means we mistyped something. The package is called ggplot2 because that's sort of the second iteration, but the function itself is ggplot. Okay, we've got some error here. Let's see. Okay. So we can see object not found. This suggests that probably we misspelled it. And then we will get something like this. Maybe something that we wanted, maybe not. And then if we add the color type, we get something like this. And it looks, I don't know, nice and colorful, but this is to show that not every representation is meaningful or a good choice for what we want to look at. In particular, here we've got all the points still on top of each other, so we don't know what other values are behind. And any suggestions? What could be a better way to show such data? We sort of group it by species ID. So each of those is a group. We might want to maybe even have a plot for each of the group or something like this. And
wouldn't a histogram plot by group be?
something like this might work. Let's quickly. So we keep everything the same. So I copy paste this chunk, but now we'll explore a different geom. Box plot for now. So it will be less detailed because box plots summarize the data, showing interquartile range as a box and then the mean or median as a bar in the middle. But this might be a more meaningful way to summarize data. Okay, let's see if violin works. With different views where maybe the distribution is a bit more clear. So this way you can fairly quickly explore different visualizations of the data. Okay. And this brings us to 11 o'clock. So let's take a break here and then we'll look at line plots next. What questions do you have? So hopefully you were able to produce the box plot. I'll copy this into the shared doc as well. So you can see how we can, by changing geoms, also quite substantially change the visual output. Okay, if there are no questions, let's take a break and I'll see you back at 11:30. Okay, welcome back everyone. Hope you had a good break. So let's continue our exploration of grammar graphics and ggplot. So we're now in the materials in the plotting time series data section. So first let's calculate the number of counts per year for each genus, and then we'll plot it. How could we summarize the data using tidyverse verbs? Okay, we're speaking about the count, so we can use the count function, and then we want to summarize. We want to count per year for each genus. Okay, this will. So this should appear in our environment. Yearly counts. We can inspect it. We've got some numbers. And now let's try plot this. Using geom line. Still need. So this is the rough. So we need the data and aesthetics mapping, and then the geoms using this plus. This means we can use multiple geoms. So for example, we could use a line, and then we could still plot the dots if we write plus geom points here. But let's not do this for now. So the data will be our new subset, yearly counts. And then the count. But if we plot this, we will see this awkward line plot where the data is sort of jumbled up. Let's see what's happened here. So the data was not grouped as we wanted. To correct this, we need to also add the group mapping. And if we rerun this, at least we've got now a different line for each group. We'll gradually improve this presentation. So another way to automatically group things is to use color instead of group. This will also imply grouping. So if we run this, now we've got also the legend included in the plot and counts over the years. So we can see there's been some dips in observations. Okay, let's have a quick poll. Hopefully you were able to get to this point and you could see the same lines appear in the plot pane for you. Please add the plus for yes or no to the poll on line 571. Or let me know if you need some more time or encounter any errors. So we can also use pipe operator instead of this specifying the data. We could write this in a slightly different style, where we plot whatever comes out of a pipeline using the pipe notation. But then we also need to specify mapping explicitly by name. So this should produce the same plot, but now you could see how this whole thing could be a result of a multi-stage pipeline that does some selecting, filtering, mutating, and then prepares the data that we don't store explicitly but plot directly. And I should mention another way briefly. So we can store a graph itself, give it a name, and then the steps we've done could be written in a different style, like so. So we incorporate the analysis, so the counting, as part of the creation of the figure. So we then use the pipe symbol to forward this as input to ggplot, and then I'll copy this last part. So now when we run this, and we see how ggplot works nicely together with other tidyverse functions. So we've got a new object in our environment. This is a graph, which is a list of things. But this is also including reference to the data. So now to plot this, we can call this object. This is something new as a concept, that some objects define a way so that they can be called as a function. And this creates a graph. And we could see that's a new graph when we go 3 times. Yeah, this was a new one created. So we can delete graphs we don't need. And then if we rerun this again, we'll get the graph. So we can also pass this on later to a function to save a graph. But first, let me check the poll. Okay, everyone got there, that's great. So another important topic is faceting. So if we want to plot each line in a separate plot, we can do this using facets. Let's go back to this style where we say data. We will use yearly counts again. The statics will be same as before. So the counts, we will use geom_line. So we want a line plot. And now this is the new part. So we could add a facet wrap definition. And we need to specify what will be our facets, and we will facet by the variables in genus column. If we run this, we could see we will have a grid of plots. And this might be, for some cases, easier to read. If we've got many lines on top of each other, then separating them into separate plots might be useful. and they are directly comparable because we kept the scales the same. So now let's see. We've got no grouping by sex in this, but to show that we could have multiple lines in each of those plots, we can create yearly counts by sex as well. And we can use, we start again with the surveys complete, and you can see we don't change this data, we use it as a source every time, but then we get a new intermediate data frame to work with. So we count now group by 3 things. This will appear in the environment, and then once we've done that, we can do the plotting bit. Okay. In the interest of time, I'll copy paste this, but always be careful when copy pasting that you adjust every part. Otherwise, you might still get a successful call of the function, but then might get slightly different result, but not see it until later. Okay, we will use our new grouping for coloring, and then we'll keep geom line and facet wrap. So now what we expect is to see 2 lines colored by whether the species were of male or female sex. And then here we go. We can see if there's any trends, or seems to be that they track each other quite closely in this data. There are various ways to arrange. So we're not going to look much into this, but there's also facet grid, something that you could look up in your own time. So we can group those. We have more control over grouping. We could have 2 rows, 3 rows, 2 by 2, 3 by 3, and so on. So we could split also by sex and have different blue lines at the bottom and corresponding red lines at the top, things like this. So this is all also in the materials, the examples, but I will jump over that example to move on a bit. Another thing I will not mention is themes. So if we add something like plus theme black and white, for example, to this plot, yeah, with the plus it's the same, and the plus must be on the end of the line. But themes are some predefined style, so you could see it's a bit more clear. This style prints better with black and white printers. I mean, there's not a huge difference, but you could see this a bit more clear. The background is not gray. With gray background is nicer to view on the screen. So when you're designing presentations, you might prefer the gray background. When it's for publication, you might want a more light background. What questions have you got? For now, I'd suggest we practice this a bit more by doing an exercise. Okay, the task is to create a plot that depicts how the average weight of each species develops through the years. And feel free to explore other geomes if you look through the cheat sheet. I'll post it into the shared doc as well. Feel free to share your solution so we can discuss it together, or if you've got any issues. Yeah, when you look at the cheat sheet, you will see there's quite a lot extra features available and customization. It's possible to place labels at specific points. You can change the shape of the points. If you do a point figure, you could use jitter to place dots over the boxes in the box plot and so on. So let's have a look around. Let's spend a few more minutes on this. So we could start by defining a subset of data we're interested in. We'll take it from the complete survey data frame and group it. So average weight through the years. So we will need the species ID and the years and average weight. So this is also a clue. We might need to perform some calculations first in between. Yeah. So first we can see if the grouping has worked and examine the data visually. But then we still need the average weight. How to get this? We will use the function summarize again. And this will use the groupings to get the mean weight. So there was a little notification message that it uses one of the parts to group first. Let's see what we've got. So we've got by year, so we've got the years first and then species IDs. Okay. So now that we've got the data, we can work on the plot part. I prefer to arrange it with kind of shorter column width. It's a bit easier on the eye. For those who then read your code. Okay, I'll use geometry. Let's have the black and white theme just for fun. Something didn't quite work. But we've seen this figure before, so this suggests some grouping hasn't happened. Or at least not in the way we expected. Let's see, we can perhaps separate species ID into separate plot each. But we need to not forget the pluses on each line. Okay, I'm not sure, maybe I'll go to typo somewhere here. Vars. Okay, yeah, var is a thing. It might give you a variation or something like this. We want the variables. So sometimes there might exist a function that does something to the data, and you get the less clear error message. But often it's yeah, a wrong function or something like this. Okay. Before we move on to customization, let's have a quick poll whether you've got this. Or maybe you've got a different plot. Feel free to share. Okay, let's not run a new plot. Please let me know if you're still doing this and need another moment. Otherwise, we'll move on. Okay, there was a suggestion here. Okay, do you want to discuss this?
Yeah, no, it was just an example that worked. So I think the when you sort it by colour, you get the different groups in there.
Right, yeah, okay. So, well, let me copy paste the whole thing and run. Okay, so this plus, I don't know if this will just silently be ignored. Let's arrange it slightly differently. So this way we can see what's on which line. And this will be marked as commented out. If I try run it, maybe it will complain. So if we see this plus happening, it means the input is somehow not complete. So we can either complete it or press escape. Okay, I just need to change the naming. So if we comment this out, this should run. Okay, we've got separate line for each. That's also nice. Any particular hypothesis what's going on here? I think most have kept their weight fairly intact, except this guy. Some odd jumps going on. Yeah. Okay, customization includes changing colors, changing labels, and so on. And we're also gonna only scratch the surface of this, but yeah, let's see how far we get. We've got another hour. If you've got any particular topics you would like to look into again, or a particular geom to explore, we could perhaps fit this in. Let me know in the chat. But for now, let's go back to this, our yearly count. Yeah, like this. So I'm gonna copy this onto line 585. So this is the code you could take, or you could take it from your source code file. So here we've got this. If we run this, we've got these lines. What we want to change is perhaps the labels. N is not a great label, and there's the years are quite jumbled up together. If we stretch the figure, this works, but yeah, we might want to add a title or something like this. So let's see how to do this. And we can do this by using the labs function. So this is, we can specify the title. If we already use a caption in our minor script, probably we wouldn't need a title, but if we want to use this say in the presentation, maybe we want to have it in the figure. Let's make the title. And then we can also specify the axis labels. X equals, and we provide a string for each. So we can specify something like year observation for X and number of individuals instead of N. and then we need a plus again if we want to keep the theme attached. And then if we run this, we say rerun, we can see the labels have changed. Another thing we could add is kind of text font size, tweak it a bit. This is part of the theme customization. And again, I refer you to the documentation for all the details, but we'll have a look at a quick example here. So we increase the text size to font 16. I think it's 16 points. So now it's kind of a bit more clear, a bit larger. And if you click on the zoom button, you will see it in a separate window, and you can redrag the window to the size you want. But now we've got the issue with the years being quite close to each other, overlapping. So which we could fix perhaps by rotating it 90 degrees. And we can also change the name of the genus to italics as we go along. So let's add a few elements. Also, don't worry if you don't copy and everything. This is in the materials as well, so you can review those elements in your own time later. So we can add things to this, to the theme notation. So one thing will be strip text. And we need to use this element text function to wrap this setting. Set it to italic, and then we need to make sure all the parentheses are correct. And there are no typos. Something like this, let's see. No. Okay, so now this is in italics. And sort of build it bit by bit. What else is there? There's a thing called axis text, and we have both X and Y text. Okay, for Y, let's just change the size and color. In the interest of time, I'll take it from the materials. So we can see how the editor also shows the color. This is the feature of RStudio, that it shows the color that has been chosen. I wonder if there's gray 30. Yeah. So we've got color, size, face for the text, and then the last bit for the X text. We keep the same starting bit, but then we also add we make it X, and we add the angle. and then a few more values for just justifying the elements centrally in vertical and horizontal direction. And the documentation contains some help on what values are supported that we haven't used. And we see this, I'll stretch it here, but I suggest you click on the zoom button and you'll see it in a separate window that can be resized more easily. But you can see we've got the italics bit and now the years are arranged. We can change this to 45-degree or different slant and so on. This is mainly to demonstrate that a lot can be done with the settings. What questions have you got?
So will we be covering how we save these plots in the various different data formats like PDF or PNG or JPEG?
Yes, let's do this next. This is the exporting plot section.
We'll also
jump over a little bit that's called patchwork to group plots, different types of plots together in one. But this is also the material. Sorry, you were saying?
Yeah, also how to save to a particular DPI, dots per inch, because some journals require 600 DPI plots.
Yes, we'll cover this next. So there's a function called ggsave, which can be used instead of to look at the figure. We can use a function for saving a plot, and it's got a lot of parameters that can be used to configure units. This is the dot per inch, the DPI resolution, and it supports different formats. And this is roughly the example of how it can be used. So first we sort of create the plot, and then we need to save it. And instead of appearing in the plot display, it will appear maybe in the figure subfolder or wherever we specify we want to save it. Okay, so let's take the plot we just had. You can edit the code that you had. I'll copy it because I want to keep the other one intact for now in case we break things. And we'll save it as we've seen before. Let's call it my plot, but it's probably a better name. Okay, I think I forgot a bracket at the end. Yeah, for each opening bracket we need a closing one. Wait. Even two? No. Okay, sorry, I need to have a quick look what's going on. So results of calling ggplot we want to save. Yeah, sometimes that's the danger with copy pasting. You miss a character and then sometimes it might not fail with an error, but it might give you a wrong result silently. And it's yeah, need some care when copy pasting as always. And now we can use this plot object. Let's use PNG. Then we need to provide the plot object itself, and then we can specify width and let's say GPI equals 300. So this should create a figure, and it will save an image. Hopefully, an image has appeared. So if I click on it, I can see it in a separate window, but it's so if you click on it, it will appear, and I can confirm it's there. It might not be the best height, but you should find a new plot as a file. So now we know how to export a plot. So maybe we should also specify some height to get different aspect ratio. And this will override the plot if you don't change the name. Okay, let's have a quick poll whether you were able to save the plot. Any plot, you can save another plot. Whatever was the plot, the ggplot call, you assign it to a variable and use this variable as argument to ggsave. Let me know if there are any issues. Yeah. So we're on line 607 in the shared doc. Please add a plus to yes or no if you managed to get it to work.
When you're saving the plot, is there another way to like edit the background if you wanted it to be transparent?
I think so. So there must be some way to specify, perhaps through the theme. So there might be some themes that use transparent background, and the device or the type of the figure should support it. So I think PNG supports transparent background, but some other formats might not support it. Okay, let's see. There's no example here, but there may be an example in the cheat sheet. Okay, so there is an argument I just looked up online that's so this background can take transparent, but then the theme might also need some specification, and this is yeah, maybe different for different themes, so you need to look into the documentations of each. But let's see if it works if we do this. Something is missing here. Okay. I'm not sure it's worked. You could check it with your settings. Or maybe also plot needs a background. Let's see. Yeah, there are a few more settings. So the post I found is I'll put it in the shared doc. So different elements can have different background settings. So this means, yeah, each one needs their own setting. And don't forget the commas between the all elements. Yeah, it becomes quite convoluted.
I wonder if you could, I don't know if you could just make a function or something to do all of them at once, because that's quite a lot.
There might be, I don't know off the top of my head.
Yeah, no, it doesn't matter right now. I just I wondered if there was like a one kind of line to do it thing, but that's helpful. Thank you.
Let's see if we remove this, if this setting, only the GG save setting is enough, but I don't think it will be. No, it looks like it needs to be specified. Where else? Yeah, it's likely theme specific setting. But if not, this is maybe at maximum there are 6 lines to specify like this, and you specify them once when you create the code, and then you rerun the code every time. So it's a kind of one-off effort. That's the advantage of using code that can be saved to script. So you write it once, and once you've got the perfect plot, then you can run it as often as you get new data, you regenerate the plot, but you don't need to change the code for except the file name to load, perhaps. Any other questions? So we've got some time left. We can go back to some sections, or we can have another exercise, or look at this patchwork package. So let's have another poll. So we're on line 615 in the docs. So the options are kind of in your own time, explore new geomes. We can look at patchwork library to combine plots briefly, and then we can look at measuring kind of runtime performance of your code. Using microbenchmark library. And there's also something called profviz, which breaks down the runtime by function within an expression. So this can be useful to check if you've got some code and it runs slow, you want to find out what part of it is slow. So you would want to optimize that part. Okay, let's have pluses for different bits. So we might be able to briefly fit in two things. And so far we've got to look at patchwork library. So if you haven't installed it yet, okay, patchwork. It might not appear in the list here, but this is how you can check if you've got it installed. If it's in the list, you can load it by clicking. And this should be loaded. Let me know if you've got any issues. So let's start with patchwork. This is also in the materials. So we jump a little step back in the materials. This section is called arranging plots. So if you haven't installed it yet, you would need to do install packages patchwork. That's the name of the library we want to use. I have installed it before, so I can load it. But we've already done that. I'll just take the note of it here. So we would need to uncomment this to run either of the lines. Okay, let's get a plot for weights and one for counts, and we want to plot them together as subplots of a single plot. This is what patchwork is designed to help us do. So again, we need the data, the maps, the geomes. We might change the labels. And then we can apply transformation. This is something we haven't really talked much about, but this is also defined in the grammar of graphics, that we can apply statistical transformations to data. And in this case, we will use log scale for y. The data we will use is the survey data directly. And then we'll have species ID on the x-axis. I'm wondering why the tab completion didn't work. And then weight here, and this will be a box plot. We don't need to specify anything here. For labels, this is a labs function. This is the kind of shortcut to specify this labels. We can otherwise also specify things as part of a theme, or we can place labels at XY locations in the plot, but we'll not look into this now, but it's possible to do. So, okay, let's see. Okay, this will prepare first part of the plot. Then we will have a similar plot, but for counts. This will be a line plot. And you could see how we can sort of first sketch out what we intend as a figure, and then fill in the missing bits. We'll keep the line as is, but it's possible to also customize, for example, lines, width, and things like this as part of line aesthetics. And you could refer to the cheat sheet to see how to do that. So we will use count on the y-axis and color by genus. So run this. Now we've got two objects here in the environment. The plot objects somewhere here. So plot weight, plot count. And those are, let's see if this works. Plot. So this plot layout is where the magic happens. A part of patchwork. And we can specify a kind of heights for those plots. This might be in inches by default. Okay. And we'll get something like this. And this is a nice figure. We might be able to still tweak it somehow, maybe move the legends to the position at the bottom or things like this. So there are lots of tweaks which we can still do. But that's it. We've got a plot which has two different subplots with you could of course create those separately using ggplot and stitch them together in your kind of image editing software, but this is perhaps a nicer way to do it programmatically. Okay, let's have a quick plot if you manage to get some similar result. Paul, sorry. So a plus for yes if you managed. And while we do this, let's install this. We need to install the micro benchmark package. And profviz. And then load those. Do you have any questions about Patchwork? So I haven't been using it myself actively, so I have fairly limited knowledge of that library, but usually it's a solid library if it makes it through the Carpentry's review process into the materials. But that's something I haven't seen before in the materials, so this also shows how the Carpentry's materials are constantly developing. And if you find it useful, you can also participate in the Carpentry's community more by reporting issues. If you spot a typo, for example, in the materials, you can create an issue on GitHub for those materials and things like this. And then I myself started as a learner on the Carpentry's workshop and then decided to become instructor to share these things because I thought it's fairly useful stuff. Okay, so okay. Just checking the chat. I don't think I see anything. Okay. Yeah, something like library micro benchmark will load it. Profviz should load it. And so sometimes you have multiple ways to do things and you will be asking yourself, let's say, is it better to filter first or select first? And the best way to answer this is to actually try both and time it. And micro benchmark is the library that helps us do this. Let's see if it's got an example we can reuse. Otherwise, if you have two pieces of code you want to test, you could share them in the shared doc and we will see. So the main usage is to kind of wrap around various expressions. Into the function call. Okay, let's have a suggestion for some expressions. So maybe we can find something. If we go back to the selecting and filtering part, and quickly scroll around to see if there is anything. Okay. Okay, I'll copy paste some code I was playing around before because it will save us some time.
Could you add the code for the patchwork example as well, please?
Yep.
Thank you.
So I pasted it. This is directly taken from the materials as well, so you can take it now from the shared doc to run, but then if you need to review it and reread again, there's some text sections that explain it in a bit more detail. Okay, so let's see if this works. So what we do here is first we call the micro benchmark function. This will run this code and time it, so using some timers internally. And what we do is we provide an expression and another expression, comma separated way. And we can go on and provide another expression and so on. But for now, we're comparing is filtering then selecting faster or selecting then filtering for this case. And if we run this, we can see it will take a little while and it will run and then give us some runtime comparison. So in this case, the first expression was slightly slower. So chopping off the columns first and then running actually helped to filter faster. It's like 10%. It's not huge difference, but sometimes you can see factors of 10 difference between two different types of code. And micro benchmark is a way to spot it. ProfViz is similar, so it also wraps your code into this time of ProfViz function, but then we need this kind of syntax. We say our code is wrapped into this expression notation, so as a block. And if it's a very small piece of code, it needs to run many times until it gets some reasonable numbers. So this is what this rerun true does. And there are a few more configuration options. We're not going to look at those because we're running out of time. But if we run this, it will run until it gets some numbers. And it might not show much in this case because it's a very small piece of code. Let's see. Yeah, so it shows memory usage or data usage. So maybe we could profile. Let's see if this will work. Perhaps we could profile this call into the library. I haven't tried it, so it might not work, but let's see. Because this might be a bit more expensive in terms of running it. And this can generate ProfViz can generate HTML reports you can view in your browser and the interactive and so on. So it's so yeah, at least it shows we could follow up like a line of calls. If something is crashing inside the library, this might give you also like a trace. Yeah, that's a very brief overview. So this leaves us a little bit of time to kind of explore things in your own time. So you could find a more interesting case to micro benchmark. I'll also have a quick look around. And for ProfViz, I'm always hoping that the package has a vignette. No. Yeah, unfortunately not, but at least I want to make you aware. So this is Profibase, and microbenchmark is not in the materials, but this is something I think becomes useful once you start really using large code samples on large data sets. Sometimes I've seen code that's like 100 times slower than it needs to be because it uses some function calls in a less optimal way. I'll copy this to the shared doc as well. There is another book I'll recommend at the bottom as well. So it's by Gillespie and Lovelace. Let me check my notes. Yeah, it's called Efficient R Programming. It's an O'Reilly book. It's not very long, but it has a good summary of a few points that go beyond what we've seen here today. Okay, so to summarize, this section has introduced few more verbs to group and summarize data using dplyr, part of tidyverse. Also the mutate verb to create new columns. And then we've moved on and have a look at the ggplot, at the grammar of graphics, at the concepts of building a figure from data using aesthetics maps, and then adding geomes or geometrical shapes on top based on the data, and also using some statistical transformations. So we have seen faceting, so we can group plots or data within the plots as we need. We have seen ways to customize the labels and the font sizes using the theme function. We learn how to save the plots using ggsave function, also specifying the DPI setting. And we had a brief look at patchwork to combine plots together to have a grid of plots. So this concludes the materials for today. We've got some time for practice, like a free practice, or maybe you've got a data set that's tidy and you want to try plot your own things. Feel free to do that, and we can comment on the code. Any questions? So let's also use this moment. So I'll also ask for feedback again. I hope it was not too rushed, but there's a lot of material to get through, and the main goal is to introduce this so you're aware where to look at, which cheat sheet to find, which library to read the docs on, or which part of Stack Overflow to look at. So using tags R, for example. Okay. Any comments, suggestions, questions? So please add your feedback at lines 682 and below. So I also seen some people are from the same institution or from Northumbria, for example. So it's really good to try establish your local kind of interest group on, let's say, data analysis in R or something like this, where you can meet and share ideas, knowledge, and discuss your code, do little code reviews informally. And there are also the UK Carpentries community organizes community calls every now and then. So the few people on the community calls are also on Slack channel of UK Carpentries who are experienced with R, so they can help out. In some places, you might be lucky to have a local R meetup, which is also a nice place to sometimes see talks about new libraries, or sometimes you can also bring your problem or your code there and discuss it with someone who's knowledgeable, or more knowledgeable, let's say. Or you might be able to help someone else who hasn't participated in a workshop like this yet.
For the book you recommended, is that author any relative of Ada Lovelace?
Oh, I can't say for sure. Would be over a few generations.
It's a good surname for a programmer.
Yeah, so I've seen that, for example, Annie yesterday said she couldn't attend today, and she's also from Northumbria University, so perhaps you could reach out and maybe she's interested to hear from you what you've learned today and so on, and we could help her to go through the materials. Okay, let me check this in chat messages. Yes, so Andrew was mentioning that some climate data sets are huge, at 500 gigabytes or above. So there it might even happen that your analysis won't run at all if you try to load the whole data set in one go, and you might need to chop it up and then work file by file, get summary stats, and combine the summary stats. So stitch together data frames. We haven't looked at it directly, but Tidyverse has some functions that can help you reshape data or stitch together data frames. Okay, thanks. If there's nothing else, I'm happy to close a bit earlier. Thanks for feedback. And I'll see you tomorrow for the SQL part of the workshop.
Yeah, I'm looking forward to the SQL one, because I deal with data sets that are quite large, as I said, up to 500 gigabytes, and loading that data into memory is just not feasible. So having to do some form of filtering has to happen first. And I've been sort of looking and thinking about using or transferring that data into an SQL database where you can filter the data much more quickly to produce plots.
Yes.
So yeah,
So
so
we
tomorrow.
will look. Yeah, we will look at mainly SQL syntax, but yeah, I think this should be applicable. Yeah. So we might also see a way from inside RStudio to connect
Okay.
the database and things like this. So let's see. Yeah. See you tomorrow.
Okay.
Is
Tomorrow.
there
Yeah.
anything else? I'll stop sharing the screen. I'll be around still for a few more minutes. If there's anything else, but stop recording.